Welcome back to another episode of MedTech Trends. I'm your host Dorian. So today we have with us two guests. They're coming from Luxembourg, I believe. So I'll introduce them and then we'll get right into it. So we have Zied Tayeb, who is the CEO and co-founder of a company called Myelin-S and Myelin-H. There are actually two companies. He is a researcher on brain-computer interfaces and neuroprosthetics at the Technical University of Munich. That's TUM for short. And we also have Samaher Garbaya, who is the Chief Operating Officer and also a co-founder of Myelin-S and Myelin-H. Her background includes deep learning for object detection, recognition, and localization. She has a background in finance and modeling. And prior to co-founding these companies, she also worked in fintech. So welcome to both of you. Thanks so much for coming on the show this morning.
Yeah, thanks for having us. We are flattered you've taken the time to talk to us, and we highly appreciate your interest in what we are doing at Myelin-S and Myelin-H.
Awesome. This is going to be an awesome conversation too. I was really looking forward to this. And again, we'll get into a lot more detail about what you guys are working on with both companies, Myelin-H and Myelin-S. Before we get into that too, let me just kind of lay out the mission of these two companies as it shows up on your website. They're two separate websites, and we'll include a link in the description. And Myelin-S, which is a space technology company, their mission is to bring neuromorphic computing for in-space autonomy and making new studies in human-robot cooperation in outer space. Really, really interesting. Love to also now transition into Myelin-S. So this is a space company that you guys have co-founded, essentially based on the same underlying foundation, the same underlying software, but with a totally different application. And I found this fascinating. Again, it's one of my two big passions, if you will. Let's dive into that a little bit. Take a pause from Myelin-H. Now, to start off, I read that you guys were finalists, I believe, or won a top 10 position in the NASA iTech competition from 2019. There was a competition down in New Mexico. I wonder if you can tell me a little bit about that. And also just opening it up to, what is Myelin-S? How does it work? And how do you envision applying the same technology to spacecraft, I guess?
Yeah, I'll be just briefly describing this and then giving the floor to Samaher for further information. Indeed, we were flattered that NASA iTech picked us and selected us as one of the top 10 most innovative startups. It was back in 2019. It was a great pleasure, I think, to be in New Mexico and to pitch the idea to a couple of departments at NASA. So Myelin-S in a nutshell is, as you probably can link it to this year of doing neuromorphic computing research and robotics in the HBP project. And it's actually building a power efficient operating system that acts as a semi-autonomous brain for spacecraft and robots. And the reason why we decided to kind of go or tackle this problem is we realized by looking at the literature and also checking what NASA and other space agencies are doing is there is a problem as we are gravitating towards in-space autonomy. So we want to like robots and humans to work together and build like new infrastructure for a habitable Mars or Moon. Then this in-space autonomy is not possible because we have two problems. The first one is high latency, so we can't get the this communication fast between the human controller and the robot. And if we go with a fully autonomous system, then there is a problem of high power consumption, specifically as we want to do like deep learning and AI and pushing the boundaries of what can be done there. So Myelin-S is now proposing this kind of solution where it puts a lot of AI into the game and for in-space autonomy, but it leverages neuromorphic computing to do it in ultra low power consumption and low latency. And for those who are not familiar with the neuromorphic computing, is basically there is a problem right now as we are designing computers and microcontrollers using what we call von Neumann architecture and using the Moore's law, which is basically doubling the number of transistors every 18 months. Now, as we are reaching the limit of physics, because we are probably around 10 nanometer surface of a transistor, then we can no longer double the size of transistors within a microchip. But we are pretty much excited about AI and we want to like scale and have multiple systems. So we need to figure out a way to do that. And then some people came up with the idea of developing biologically inspired computers that they can run massively parallel. The problem is when you try to use von Neumann architecture, usually you spend the most energy and time just fetching the data from a local memory, and there is a clock which is synchronized with the whole process, and then going back and forth between the memory. That's very time consuming. That's also very energy consuming. So if you have multiple memories, you have multiple chips within the same like big chip, and it's like similar to the human brain architecture. So you can drive your car while thinking about your job, and then while reading a book, and while checking your mobile phone. So you can do multiple things at the same time. And this is kind of the dream. This is what we live for right now, is to get this in space.
I'll open the floor up to you, Samaher. Tell us a lot more about this this company and how it works exactly.
How it works? So let me first of all say about Myelin-S. As Zied say, so we provide this disruptive software operating system that acts as a semi-autonomous brain for robots and servicing satellites. So as explained Zied, we use the neuromorphic computing plus the shared control and sense of touch for different applications in space. That's why Myelin-S now we are, our vision is to attract more businesses and space companies to test our technology and also hopefully to contribute to one of the next missions in space.
There's definitely a lot of follow-up points here. So let's clarify first. When we say semi-autonomous, what exactly does that mean? Is the person still involved in any of the work when we say semi-autonomous?
Yeah, exactly. So it's like kind of this developing like something which is trustworthy. Is basically there's a human controller who acts as a very high level person that can intervene when something goes wrong. But the robotic system is already empowered with the capabilities to run those specific tasks without the human, involvement. So it's a teleoperation mode. You send very high-level commands, then the robot takes care of all the low-level commands. And for example, one of the applications we are interested in at Myelin-S is on-orbit satellite servicing. So if you have a robotic arm attached to a satellite, and then this satellite this arm is supposed to grab another satellite which is expired, or to fix this satellite, then the human controller can send just the high-level command saying, I want to grab this satellite, or I want to repair it, or fix it, or refuel it, and then all the low-level stuff like trajectory planning, force, and so on, they will be done by the robotic system itself. And then the human controller will receive the haptic feedback to tell how much, for example, stiffness was applied when opening that tank for refueling, and so on and so forth. And again, I think to complete the story, everything runs efficiently, low power consumption, talking about milliwatts, and low latency.
Maybe we can rewind a little bit too. So, because Myelin-H, I believe, was developed first, and then Myelin-S, or were the two companies developed simultaneously? And how did that thinking even come about? Because they're operating in very different industries, which is what I find really fascinating.
Yeah, historically speaking, I think one started before the other, so we could not. I think it's very challenging to start two companies at the same time. You might be surprised that Myelin-S actually started before Myelin-H. There was an R&D part, and then we stopped. Then we started the Myelin-S because there was this NASA selection. We share a big passion for space anyway. That's kind of our like intrinsic motivation. Then we started the Myelin-S company. Things take time with the space, so you have to put one foot after the other. You have to do a lot of development. It needs ferocity, persistence, and so on. So we've been waiting, but we know in the back of our head that this thing will take too much time because it's disruptive, it's new, and also space-related projects. So the timeline is probably 5 years or so to get this, to see it like in action. And then we were lucky to get the support from the Ministry of the Economy in Luxembourg. The government actually believed in us as a team and also believed in our idea. And then they said, okay, I want you guys to continue working on this project, specifically the healthcare project, and take it to the next level. And so far, we started that project in January. And since then, we have been, working around the clock on the Myelin-H to get it off the ground.
Let's expand on that a little bit. This is a question I wanted to ask in terms of your partnerships and really other agencies that have taken an interest in Myelin-S. I wonder if you can, both of you can speak to, who else is involved, who's on the advisory panel for Myelin-S, and do you have ongoing discussions with space agencies really around the world? You mentioned Luxembourg. Are there any others involved?
Yeah, so I mean, running two different projects with cutting edge technologies and big markets is actually it's a big team effort. And then we have a lot of people who are supporting us, behind the scenes and helping the company move the needle. We have a team of people dedicated for both companies, and then we are surrounded by strong advisors. When it comes to the space, we have a couple of people from JPL, NASA. We have from the European Commission for Space. Then we have also from the Singapore space agencies, like preparing itself to be a space agency. I think it's quite like a big team in terms of advisors, and they are giving us a lot of help when it comes to the space. Also in the medical field, we have physicians with us on board from Germany, from NHS in the UK. We also have business advisors. So this is a big team effort, and a lot of people are supporting behind the scenes. In terms of partnership, fingers are crossed for a new big partnership with one of the largest space robotics company. I think, I leave the floor to Samaher, but I don't want to touch on this because I want to keep it, until it's like officially unveiled. But we are working on a partnership. We are, discussing with NASA every now and then, the NASA iTech team. We have also gotten different partnership discussion with ESA. So, but things take time.
About the partnership, also maybe you forgot to mention Zied that NASA iTech, that there are a lot of companies that we are still in contact with them, and maybe we will have very soon different partnerships with them. So this is
we have a running project with a company that's not secret, so called Space Industries. One of the NASA iTech batches, or participated in one of the NASA iTech batches. We got introduced to them, and then they are developing a lunar rover for to support the NASA Artemis mission 2024.
Really cool. Okay, this is one of the things I wanted to ask you guys about. Perfect. So, so it sounds like there are partnerships, potential contracts maybe down the road. both with private companies and then also with government agencies, government space agencies. Is that the more long-term kind of vision of partnering with both private and public sector?
Yeah, exactly. I think the only way to go is to have like a partnership with both sectors. As you can see, the tendency or NASA is gravitating towards having more private companies being involved in the space sector by giving a lot of contracts. Recently, Honey Robotics, a couple of other companies, Maxar, and so on. So I think it would be interesting as the market is flourishing. There would be more private companies, and we would definitely want to, position ourselves as playing with both. And I think the good thing about space agency is there is a quote which says, like, on the shoulder of a giant you can see better. And usually with the space agency you can see better because they give you like the whole thing, but it's still interesting to keep an eye and work with private companies.
Really cool to hear. Again, I mean, I wish we can continue this conversation for a couple hours. To be honest, there's a lot of really cool stuff to get into right now. But let me also try to touch on, how do you guys handle your everyday schedules? What is that like? You're operating two companies right now. You've got ongoing research, tons of partnerships, tons of teams I imagine that you're working with. What's your everyday schedules like? And how do you coordinate with each other?
Yeah, I mean, in terms of schedule, I think it's pretty chaotic. So it's like, we're working around the clock. So you see, 13, 14 hours, that's normal, because we know you have to put a lot of sweat and tears right now. This is a very kind of crucial phase for both companies. And then you obviously have to work hard to get things done. And then also there is, I don't know what the weekend means. I mean, it has been a while. I didn't actually, I haven't taken days off. So the schedule, I think, runs from 6 a.m. in the morning till whatever, 8, 9 p.m. I can, I can just hand over to Samaher. She can talk about her schedule. But we pretty much see each other like every day.
Yeah. So for me, my schedule is really tough to explain. How is really have a lot of tasks to do. So as I didn't mention in the beginning, that I'm also a co-lead in Space Generation Advisory Council, and also a master student at the university in space at the University of Luxembourg. So I had to have a suspension this semester due to a lot of work in the 2 startups, with teams, with managing, and as well as coding. So this is something a little bit hard, but it's amazing when you are doing something that you are enthusiasts and you are happy to do something, and you see the progress day after day.
That's a lot of things to juggle. That's a lot on your plate. Wow. Yeah. Okay. So, what would you say is the main sort of the main project or the main thing that you guys have on your plate right now for space for Myelin-S first?
For Myelin-S, I think the biggest, the most important milestone is actually to get the system up and running on a spacecraft, or like a physical system, either from a space agency or a private company that's about to launch their spacecraft. So that's, I think, the most important milestone. And I think the grand vision here is to be able to see the system on the moon or on Mars. I mean, that's gonna be fabulous. I mean, it's fantastic. Last time when we were watching like the Perseverance landing, and I think it's fabulous. It's just unbelievably good to see like a rover that can, listen, collect sound, and also see what's going on Mars. And hopefully Myelin-S system, the neuromorphic architecture and the software, can be one day there to also help explore other planets, and to help, build a sustainable presence on the moon and on Mars.
I was going to ask you about the Perseverance rover and what you guys think about that. So you beat me to it. Awesome. Okay. Just I guess one final question, because I know we got to wrap up, unfortunately. But Are you looking to bring on any additional partners right now, or are you eyeing anyone? Is there anyone in particular that you have in mind, public, private organization or other, for both Myelin-S and Myelin-H?
For the space sector, we are open, and we would be interested in running a couple of pilot projects with other private companies, space companies mainly, who are about to launch, or they have their system and they want to test like a new technology and see like the benefits that can bring up to the table. So we're definitely open and be happy to discuss with any partner, both in space, robotics, or in someone who is interested in clinical trials for Parkinson specifically, and later on, hopefully on multiple sclerosis.
Great to know. All right, Zied and Samaher, it's been awesome having a chance to get to know a little bit about your companies and your backgrounds and how all of this kind of came to be. It sounds like everything is still in an early stage, but very much ramping up, and a lot of interesting things happening simultaneously. So I wish you guys all the best. I'd love to stay in touch and have you guys come back on in a couple months, even a year or so, and love to hear a lot more about what's happening with the company. I wish you guys all the best, lots of success. I think a lot of good can come from this, and I guess we'll catch you next time.
Yeah, thanks for having us. Great, it was great talking to you, and looking forward to following up on this with a nice conversation. Thank you so much.
Thank you, Dorian.
Take care.
Bye-bye, Tom.
Bye.